Hello, everyone. Welcome to today's live webinar. Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fassi, Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today we are here for our live webinar titled How to Auto-Embed in Your Tissue Processor. And in this educational webinar, we will discuss an innovative solution to automatically embed tissues as part of the tissue processing step. Milestone has been in the field since 30 years. Our mission is to reduce patient anxiety by providing pathologists with technologies for same-day diagnostic results. Before we start, I kindly ask your attention for a few seconds. In these slides, you can see the main function of the WebEx platform through which we are broadcasting. You can notice the layout icon located on the right upper corner of your screen. You can use this icon to adjust your screen display anytime during the webinar. There will be also a vertical line between the PowerPoint presentation and the live video, and you can move this vertical line to the left or to the right in order to make bigger the window you prefer. This webinar is intended to be interactive, so we encourage you to ask questions, and you can send us questions anytime by typing them in the Q&A box. We will answer some questions at the end of the presentation, and for all other questions that may not be answered live, we will reply by separate email. The slides will flow automatically during the webinar. If you have any technical problem in viewing or hearing the presentation, just write to the host in the chat box and we will try to support you. Now let's take a quick look at today's speaker. Our speaker today is Marco Perrella, Application Specialist at Milestone. Marco has graduated in biotechnologies at the University of Milan, and he has wide experience in histology and research labs, both in Italy and abroad. This presentation today will be recorded and will last about 45 minutes. Now I think it's time to start. So Marco, you have the floor.
Thank you, Michela, and good afternoon. Thank you all for participating in this webinar. Today we are going to talk about a topic which is the auto-embedding. And before getting there, I just need you a few seconds in order to share my presentation and to set the visualization mode on the computer. Good. So as you can see in the title, today we are going to talk about auto-embedding. And when we talk about tissue processing, one aspect that sometimes is it's very important to understand is that the theory behind the tissue processing has remained basically unchanged throughout the past century, let's say. And we all know the step which brings from a sample to the slide. And here I've listed the main point, of course: fixation, dehydration, clearing, impregnation. Then we do have the embedding and blocking, the sectioning and cutting. Again, same theory has remained unchanged, but we do have some innovation along this path. Today, we are going to discuss a bit more an aspect that many times is overlooked, even though it has a very significant impact in terms of the final diagnosis. So, and this aspect is the embedding. So when we talk about embedding, I'm sure you know, but it's just to focus on a restrict field this presentation. When we talk about embedding, is the process where we put a sample in an embedding medium, which allows us to cut it, to make it possible to cut. There are several medium of embedding, but today we are going to talk the one that I'm sure you are the most familiar, which is the paraffin embed medium. And this is the one, the mold that you surely know, which is the steel reusable mold. And in the presentation, you can see two salient moments of the embedding, which is one part is where you have to put the specimen onto the steel mold. Okay? Then you squeeze it with the, you push it with the forceps. And then on the other side, the other key moment is where you put the cassette on top of the specimen. And this cassette, of course, then it goes onto the cold plate. However, which are the aspects that are, let's say, more problematic? Where are the issues in this path? The first one is that it's a tiring procedure. And we all know that when we do have hundreds of cassettes, it's really take effort to embed all of them. And the other part is that it's time consuming. On average, it's one sample per minute, but of course it's an average. When you do have one sample, a single piece, relatively big, it's very easy and you take less than 1 minute, of course. But then there are some other cases where you do have several fragments, or you do have some specific alignment of the sample that you might take even more. So that's a reasonable average. And the third part is the traceability. This is also another overlooked aspect, not always considered. But when we take out a cassette from the processor, how can we be sure? For example, we do have 5 fragments in the cassette. How can we be sure that all of them are going to be placed in the cassette, in the mold, sorry. Okay, so this is just an example for what I mean for traceability. And when we look at this aspect, okay, can speed and traceability coexist in this procedure? And here I've listed all the paths from accessioning to diagnosis. And throughout the years, as I said, the theory is the same, okay? But there have been some striking improvement in this path. And from accessioning, for example, we do have the implementation of the LIS system, which track down the patient identity and so on. Then we move towards grossing, and we do have grossing table where a documentation device have been implemented. So now we can do the grossing, and very easily we can track down all the imaging, documenting, taking video and audio recording, for example. Then we move towards tissue processing. And for example, I do have a processor behind my back. And this processor, nowadays, they have a really high throughput. Right? We are talking about new technology that allows to increase hugely the number of cassettes we process. After the tissue processing, we move towards embedding. Embedding is still done manually. So no big improvement has been done in the past years. And then again, we move to cutting. And here you can see a semi-automatic microtome, but thanks to semi-automatic microtome and automatic microtome, again, you still have an increased number of samples that you can work and bring towards the final diagnosis. So under this light, we can see that the embedding is the bottleneck. But what about if we can skip the embedding as we know it and move it towards earlier phases of this path? For example, we can start to do it at the grossing. So what I mean that operator, which does the grossing, can also start to work and position the cassette ready for the embedding. And we will see in a few moments how this would be possible. But in order to change something that it has been basically the same in the past, since ever, basically, we have to innovate and not just with a simple improvement. To explain better what I mean for this difference, here you do have an example of improvement. Everyone who has more or less my age has played this cassette for music. An improvement at that time was to move from 60-minute cassette up to 90-minute cassette, which meant at the time a bit more music, but with the same problem. We just, for example, the disentangle of the magnetic tape and so on. An innovation after that was, for example, the upcoming of MP3 player. And in the past year, we are also facing stream music, okay, which brings to the user an unlimited amount of music. Okay? So that's what I mean, a difference between improvement and innovation. And bringing this concept to our situation of today, which is the embedding, we can see that given the fact that it is a manual procedure, there is not too much room for improvement because we cannot improve the manual dexterity of an operator. Okay? And in the picture there, I mean, I just meant that we are still far from a robotic positioning of the sample inside the cassette. But we can innovate and we can move from this kind of sample, steel mold, which is the traditional positioning, up to this synergy cassette, okay? A completely new concept that we are going to see together a bit better in the next few slides. So what is synergy? Synergy is a system, an innovative system, which brings processing and embedding all together at the same time. So, and you can achieve these two steps simultaneously. And now I'm going to show you step by step how is composed the synergy system. Basically, what you do have is you do have a synergy rack. Just let me zoom a bit more. You do have a synergy rack where you load the cassette, synergy mold, which is very analogous to the mold we saw earlier, and where you do have, you position your specimen of different sizes. You do have a standard one, a bit bigger, and biopsy for very small specimen, and a pad. I just use the white background over here to show you the pad. Even if this one is a very small part of the system, has a fundamental and big importance. Because as you can imagine, this has been optimized for better processing. You can see in the picture of the presentation, you can see a comparison side by side, same magnification of the Synergy Ultrastructure, okay, for the Synergy pad, versus a standard sponge. And you can see from the white spot, which is basically the light that comes through, how the Synergy has been developed to have open pore, which facilitate the passing of the reagent in order to achieve the optimal processing. Then another aspect to consider is that those pads have been developed to have wax-like properties. So it means that when you cut it, it has the same mechanical resistance to be cut for the blade. And then, of course, even the softness has been developed in order to be, let's say, hard enough to maintain the specimen in position, but soft enough, of course, not to squeeze it, for example. So a lot of effort have been directed in the towards the optimal path for synergy. With these three factors together, these three players together, that's how we move from grossing straight to cutting. And we will see together how does it work. Now, here you see a quite famous slide. Taken, I put also the reference, and basically where is listed how all the specimens should be placed for when we speak about embedding. And that's really what I'm practically doing today. So step by step, you can really practically see what I mean for positioning and how I do position the sample in synergy. For example, the easier case would be a big, thick specimen, 5 millimeter specimen. I just place it on the cassette, on the mold, and then close it in the cassette. This one will be loaded in the synergy rack. First sample is done. Then, as you can see, let's say we want to position an elongated sample, and we will place it diagonally as shown in the slide. And in order to do that, I place it diagonal, and then I put a sponge on top. This sponge will allows me to maintain the specimen in position throughout the entire procedure. Then another case will be for example, we want to place the specimen perpendicular to the cut. And then what I can do, I just cut the sponge in two parts. I put the first part of the sponge, then I place vertical the sample, and then the second part of the pad. So this one being a bit more tricky, I can show you a bit closer how easy it is also to achieve such a configuration. Then I just close it and load it again. Another sample which is very common is that, for example, you do have tiny fragments like a GI. And even in this case, I can take my sample, put it in a smaller mold. And then, of course, I will use a smaller pad to keep it in position. Of course, in this example, I've just done, let's say, the most common one, the most common configuration for cassette for loading the sample. And now what I want to show you is the rack. Okay, now let's say that you cover, you fill the entire rack, and the peculiarity of Synergy rack is that you can move those ladder. Hope you can see, but I do have a practical example to show you much better how does it work. In the slide is explained how basically the principle. When it's inside the reagent, the ladder and the sample will be oblique. These are angle of the sample which allow the reagent to freely flow inside the cassette. When it will be time to be in the works phase, okay, the cassette will be horizontal and they will pick up the works. One thing that also I want to show you is the internal part of the rack. You can see that it's empty, and this is in order to have a free flow of the reagent. As promised, now I'll show you the practical example. You can see that I prepared a simulation. Let's say I will use your imagination now. Let's say that now we are inside the cavity of the tissue process. Now, this liquid is the fixative, can be the ethanol, or the entire phase. And basically, when you are inside the cavity, you can see how your specimen will be diagonal. So now all the processing can be freely done, doesn't have any obstacle, okay, and so on. When it's time, now let's say that this reagent is now works. What happened is that I lift up the racks, you can see that they become horizontal, and then I can take out my cassette. Again, consider that this is works. You can see how each cassette is full of works. So that's what I'm pouring now. Let's say it's works. What I need to do is simply to go at the cool plate and let it cool. It's very, very simple. And that's how you skip the entire the entire manual embedding. Good. So as a recap, so the advantages here is that you have one-time handling of the process. So the same operator which does the grossing can also start and position the cassette as I did it so far. And very, very important is that it's not going to disrupt your routine. Okay? This system can be just integrated in your routine. You can work, have some part of your routine done normally, and then when necessary, you can integrate synergy. You can still work overnight, over weekend, and you can process specimen of any kind of thickness, from transplant up to 5 millimeter specimen. And then, of course, you can cut it with your microtome and doesn't require any specific, for example, reagent. One thing more that I want to show you, so let's say that now I place my sample onto the cold plate, the wax has solidified, and I want to show you a bit closer how does it look like. So now I do have the mold. I just need to pull it along the fracture lines of the mold and then take out. That's what you get. I'll just let you have a closer look, and you have the sample which is really towards you. What does it mean? The text to the sponge, you do not have to trim a lot. It's already there. Plus, of course, the sponge, as I said, it's it's developed to have the same properties of wax, so easy to cut, and does not interfere with any staining, for example, or any immunohistochemistry. And very important that I'd like to remind is that this system, you do not need to have a different instrument to do the auto-embedding. You just to integrate these accessories into your tissue processor. Now, of course, you are wondering how does it look to cut it, and in order to show you that part, I'll ask Lisa support, which is my great colleague, and I'll just stop this sharing, and I'll let you, and then I switch the camera as well. Okay, just give me a few seconds. I need to go out from the presentation. And I need to change the camera. Sorry for the waiting. Now, my great colleague Lisa will show you how does it work to implement the Synergy cassette in your routine. Just let me zoom in on the microtome. As you can see, Lisa has just taken the cassette, put it on the microtome. She's trimming just slightly, and she will be ready to pick up the sample, the ribbon, sorry. You can see that it's really look like cutting a normal cassette, how the ribbon is coming out. Hope you can see it with the thanks to the camera. Okay. You can see that it's not going to work in a different manner. Good. So thanks to Lisa. Now I will move back to the main camera, and I'll give you all the time to make any questions.
Thank you, Marco, for your presentation. Now I will read the question. So first question for you. Is it required a specific type of paraffin for this method?
No, not at all. Okay, one of the beauty, and it's, I say one of them, is that you do not have to change your routine. Whatever you were doing, same paraffin you were using for tissue processing, yeah, it's gonna be the same. Same story goes for the reagent. If you are working with the configuration ethanol isopropanol, you are not gonna change that configuration. And same story goes even for the cassette that I use for closing the mold. Everything stays the same. Everything is standard, no specific needs.
Okay, let's move to another question. Which kind of specimen can I process?
Flexibility is very important. So that's why it's a flexible system. You can process from very thin sample transplant up to 5 millimeter sample. Again, whatever you were doing before, let's call it before Synergy, you can still do it. You can still work with every kind of specimen.
Okay. And does the Synergy method apply to any tissue processor?
It applies to Milestone tissue processor. And for example, behind my back, I do have Magnus, which is one of Milestone tissue processor, but also apply to Logos and to Pathos Delta. You can start working with your tissue processor, and you can implement Synergy whenever you want, as part of your routine or to substitute your routine.
Okay. And another one, is the Synergy method compatible with automatic microtomes?
Absolutely, absolutely. As you could see, Lisa, this is a semi-automatic microtome, as you could see, but Lisa has just taken the cassette and placed it over there. The cassette size is the standard one, and indeed you can use for closing any kind of standard cassette, and you just put it there and work. Of course, it works also for automatic microtome as well.
Okay, thank you, Marco, for your presentation and your answers. Actually, time is running out, so for all questions that have not been answered, we will reply by separate email in the following days. Thank you, everybody, for watching and participating. If you wish to receive any material from us, please do not hesitate to contact us. Also, our application specialists are always available to organize customized virtual demo based on your requirements and needs. If you wish to keep up to date with Milestone new live events, we suggest to check our website and follow us on our social media. Starting from tomorrow, this webinar will be available for on-demand reviewing, and you will receive an email message once it is available. The schedule for the new series of Milestone educational webinar will be published soon. Thank you again for your attendance and interest, and we hope to see you all next time. Goodbye and arrivederci.
Goodbye.